So here's part C of problem number 3 from 2009, A, B, and BC Form B. And in this piece of the problem, it tells us to try and determine if there's a value A, and A has to belong to the interval from -4 to 6, for which the mean value theorem applied to the interval from A to 6 guarantees a value C, where C is between A and 6, at which f prime of C is equal to 1/3. Justify your answer. So this is a mouthful. It's a pretty big question that they ask you here. What I have being enlarged here is the mean value theorem. And what the mean value theorem says is if you have a continuous function on the interval from A to B and it's differentiable on that interval, then there's going to exist a number C in between A and B such that f prime of C equals the average rate of change of the function within that interval. Now, what we want to do here essentially is we don't know what A is. Okay, we know that A is the left endpoint of the closed interval that we're supposed to consider. We do know that the right endpoint is 6. Right? So if we toss a 6 here in place of B, C is going to have to be between A and 6, and then we could put a 6 here, and we can also put a 6 here. So basically what this is saying, is there a value A, which isn't specified, that belongs to the interval from -4 to 6, for which this average rate of change calculation is going to equal 1/3? If there is, and as long as the function f is continuous and differentiable on whatever interval we list, then I guess the answer to this question would be yes, and of course it asks us to try and justify why we're answering the way we are. Here's what I'm going to do first. I'm going to say we shouldn't even consider anything to the left of 0. Right? If we consider anything to the left of 0, you know, if you went from -1 to 6, this piece of the definition of the mean value theorem is violated because we'd be crossing this value that the function is not differentiable at. And in order to use the conclusion of the mean value theorem, your function has to be differentiable on the interval you're considering. So we shouldn't consider any of the x values from -4 to 0. We shouldn't consider the x value at 0, because if you consider the x value at 0, you're going to have a negative slope for the line segment connecting this point to this point, and that negative slope is really the average rate of change of the function from 0 to 6. You're not going to want to consider any values up until 1. You're not going to want to consider 1 because it seems like if you draw your line segment across right here, the slope of that line segment would be 0. What I'm going to do is I'm going to start with this number right here, just because I'm looking at this point and I know what the y value at that point is, because it's the point where they tell us in the problem statement our graph is tangent to the x-axis. That means we have to touch the x-axis right here. So we know what f of 3 equals. F of 3 equals 0. And if you look at this line segment that we draw connecting the endpoints of the interval from 3 to 6, you might believe that the slope of that could very well be 1/3. So I'm just kind of picking that, and I'm thinking about whether or not I can compute this slope. I'm going to erase this and shrink this back down so we have enough room to do the work here. So what would the slope of this secant line be? Well, the slope of that secant line is going to be f of 6 minus f of 3 over 6 minus 3. Let's see, f of 6 is 1, right? That y value there is 1. F of 3 is 0, right? We're tangent to the x-axis, so this y value right here is 0. And then in the denominator, 6 minus 3 is 3. 1 minus 0 over 3 is 1/3. So we kind of luck into this result by checking the one point on the graph that we knew the y value of for the positive portion of the x-axis, other than at the end of the graph at 6. And so we do have a function f that is continuous from 3 to 6, and it is differentiable from 3 to 6. Although f is not differentiable in the entire interval, it is differentiable from 3 to 6. So there's going to exist some value c in between 3 and 6 where the slope of the tangent line would equal the slope of that secant line. So I'm trying to draw that tangent line in. This secant line is supposed to be parallel to this tangent line. Now, we don't know exactly what that c value is. It seems like it would be somewhere in between 4 and 5. But if we knew what function graphed this piece of the curve, we could then determine what that value was. But yes, there exists a value, because when we apply the formula for the average rate of change, or the slope of the secant line, to the interval 3 to 6, we get a slope of 1/3, and the function's continuous and differentiable on that interval.